Okay, so I'm on the wrong thing. Okay, so second section of chapter 6 is called talked about the number of elements in a finite set. So we spent the first section talking about what is a set and unions and intersections and complements. And so this talks about something that we're going to talk about a lot with probability called combinatorics. That's a fancy word, isn't it? And those are just problems that require you to count the number of elements in a set. And so if A is a set, then this is how we show the number of elements. So N of A, oh, that's not what I meant to do. N of A represents the number of elements in the set. Okay, so you need to know that means the number of elements. And so if A is 1 through 20, B is the set AB, and C is the set 8, then the number of elements in A, right, you got to know what that means, would be 20. And the number of elements in B, A and B, there's 2. How come this works great until I start recording? And then it doesn't want to work. 2. And the number of elements in C would just be 1, right? There are 2. There's 1. And this one, I meant to cover this up, but if I ask for the number of elements in empty set, there's nothing in empty set, so there are actually 0 elements in the empty set, right? Okay, so what about if I talk about the number of elements in the union of A and B? So if A and B are disjoint sets, remember what disjoint means. It means they have nothing in common. And so if they have disjoint sets, you are just going to add up all the elements in A and all the elements in B. So, yet again, I'm just going to sit over here and do this. So, if they're disjoint sets, that's the big if part of that, you're just going to add them up. So here's an example of this. It says if A is ACD and B is BEFG, then find the number of A, the number of B, and the number in A union B. So the number in A, how many elements are in A? 1, 2, 3. The number in B, 1, 2, 3, 4. And since they have nothing in common, the number in A union B would be 3 plus 4 or 7. Right? Hopefully that makes sense.
If there's anyone in the building that wants 3 state fair tickets, come to the main office. I have 3 state fair tickets to the first person that comes to this office and gets them from me.
What if A and B are not disjoint? Remember that disjoint means they have nothing in common. So if they're not disjoint, they're going to overlap. So you got to be really careful when you're finding the A union B, because you don't want to count what's in the middle twice, right? So there's a couple ways to think about it. One way to think about it is that you can take the number of elements in A plus the number of elements in B, but then you have to subtract out the number of elements in A intersect B, because otherwise you're counting it twice. There's a nice proof in your textbook of this, but basically it says you can think about it as if you call this part X, this part Y, and this part Z, you're kind of adding those up separately if you think about it that way. But basically you have to cancel out one of the ones that you've counted twice when you do this. Okay, so that's the part you got to be really careful about. So if A equals A, B, C, D, E, and B equals B, D, F, H, what is the number of elements in A union B? And I think you should practice thinking about that. You're taking the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. So if you think about that for a minute, if I wanted to draw it out here, see if I can fit this stuff in here. I should make my intersect bigger, right? So if this is A and this is B, this would have A in it, but B would be in the middle. C would be in A. D would be in the middle. E would be here. B, D, F, and H. So how many elements are in A? 1, 2, 3, 4, 5. Plus how many elements are in B? 1, 2, 3, 4. Minus how many elements do they share? Well, they share 2 of them. So 9 minus 2 is 7. But if you do it in the Venn diagram, you can kind of just see if you do what's in this side, it's 3, plus what's in the middle is 2, plus what's over just in B is 2, and again you get 7. So there's kind of a couple ways to think about it when you're doing that. Hopefully that makes sense. And then the last one here, 3 parts, but it says let A and B be subsets of a universal set U, and suppose that the number of elements in U is 100, the number of elements in A is 60, the number of elements of B is 40, and the number of elements of A intersect B is 20, and then we're going to compute each of these. The first thing that I'm going to do on this is I'm going to kind of think about it in terms of a Venn diagram, because I think that's going to make life easier. And so if A intersect is 20, A intersect B, and this is A and this is B, can you think about how many elements would be left in A and B? So if A has 60 in it altogether, but 20 are in the intersect, that means there'd have to be 40 in A. And if there are 40 in B, there's already 20 right there, so there'd only be 20 right here. And so if you think about it that way, I think it's going to make these a lot easier. So if I want to find the number of elements in A union B, first of all, I know there's 100 altogether. So 40, 50, 60, 70, 80. That means there's 20 out here in the universal set that aren't in A or B. That's kind of important. So A union B is going to be the number of elements in A plus the number of elements in B minus the number of elements where they overlap, right? Oh, why does it keep doing that? Then I'm going to get 80 as my answer. So I want you to think about B and C, and then we'll start there in class.